What's good, everybody? In this video, I'm going to break down the laws of exponents. I'm going to go over each law, and then at the end, we're going to come together and do a mixed review. Really hope this video is helpful for you. So the first law we're looking at is the product law. And this is just saying that when we have the same base and we're multiplying with exponents, we can add the exponents to get the same answer. So an example of this would be x squared multiplied by x squared. If we were to write this out, we would have x times x for the first x squared times x times x. And what we can do with these laws of exponents is basically abbreviate and write it as x to the fourth power. So when we look at our examples, this is how we would solve for this law. So the base that we're looking at would be x. So we know 4 times 3 gives us 12. And when we add our exponents, we would get x to the 7th power, and that would be the final answer. Now, problem number 2, they're going to try to trick us, but when we're working with just not exponents, just variables, remember, like bases with like bases. So we have x to the third plus x to the eighth. That's going to give me x to the 11th power. And then when I add y to the 5th and y to the 10th, I'm going to get y to the 15th power as a final answer. Now, problem number 3, what they like to do is throw in parentheses to make you believe that they are talking about the power rule, which I'm going to talk about next. So don't fall for that trick, all right? So what we do here, we multiply 3 and 5 to get positive 15. And then after we multiply x to the third with x to the fourth, we are going to get x to the 7th power. So this is just a basic overview of the product law. We're now going to go into the power law and talk about how to solve with those type of problems. In this part of the video, we're looking now at the power law. And all that is saying is that, hey, if we have a base that's raised to an exponent and we have another exponent to the outside, we are going to multiply those exponents. An example would be this right here. So our base of x is raised to the 2nd power, and it asks us to raise it to the 3rd power. So if I multiply my exponents, I would have x to the 6th power. Because basically what they're saying is we're going to take x squared and multiply it by itself 3 times. And when we look back at the product rule, when we're multiplying with the same base, we just add exponents, and this is how we get our answer. Now, when we're looking at our second example now, guys, it has a power of 2, and we're going to apply slash distribute that exponent to everything in there. So we're going to have negative 5 to the 2nd power, x to the 3rd times 2, and y to the 4th times 2. So when I simplify this now, I get positive 25, x to the 6th, and y to the 8th as a final answer. And then in our third example, this is what we're going to see in a mixed review. Just want to give you a heads up. So they mix a lot of these exponent rules, and that's what makes it so complicated, right? So here, they're saying we're going to take x to the third, y to the 3rd power. So when I multiply 3 times 3, I'll get x to the 9th power. And when I multiply 3 times 3 again, I'll get y to the 9th power. Then I bring down the rest of my problem, xy to the 2nd power. Now we just moved from the power law to the product law. What does that mean? We're now just multiplying with the same base. So when we're doing that, we just add our exponents. We know there's no exponent over this x. Anytime you don't see it, always understand that it's 1. So 1 plus 9 will give us x to the 10th power. And then 9 plus 2 is going to give me y to the 11th power. And that would be our answer. Now, in the next part of the video, we're going to look at fractions and the quotient law with laws of exponents. The quotient law, guys, is probably one of the easiest laws to identify because we know we're going to have a fraction. And when we have this rule, it's just saying that, hey, we have the same base, we are going to subtract our exponents. And this is basically what's happening. So if I wrote out x to the 6, right? All over x squared. We know fractions, they cancel out. So that's gone, that's gone. What I'm left with would be x times x times x times x. And remember, we could abbreviate this as x to the fourth power. So once we subtract 2 from 4, we would get x to the fourth power, just so you guys understand. Now, in our second example, right, we're working with x to the 6, y to the fourth divided by x squared y to the third. So once we subtract, we're going to have x to the fourth, y. We don't need to put to the first power. It's assumed when we don't see an exponent. So this would be our answer. Now, let's say we have a problem where there's coefficients in front. We're just going to treat it like a regular fraction. So 14 divided by 7 gives me 2. When I do 2 minus 1, that's going to give me x. 2 minus 1 is going to give me y. And this would be my final answer. Now, in this last example, just want to give you guys a heads up on how it's going to look once they probably give you a real situation. And when I mean real problem, I'm just saying, hey, this is what it's going to look like 9 times out of 10. So if we wanted to solve, right, we notice that we have an exponent on the inside of the parentheses and an exponent on the out. So just remember that the exponent is only over the top part of the fraction, so we're only going to apply it there. So 3 to the second power gives me 9. X to the fifth, so 5 times 2 gives me x to the 10th power. And this is all over 27 x to the third. Now, once I simplify this, right, 9 over 27 is 1 over 3, right? X to the 10th minus x to the third is going to give me x to the 7th power. And just so you guys know, we do not need to put this one here. We could just have x to the 7th divided by 3. But now we're going to go over to the last law of exponents, and then we're going to go to the mixed review. Make sure you stay around to the end of the video. So the negative exponent law, guys, could be very tricky for students if you just forget and misunderstand the reciprocal, okay? So what it's saying is that if we have x to the negative a power, negative exponent, we're going to take its reciprocal. So if we look at problem number 1, that negative exponent can't be there. We cannot have negative exponents. So as a result, I turned it into a fraction, and only the term that has a negative exponent is going to go to the bottom, which is just x to the negative 2. So my answer will be 5 over positive x squared. Now, what they like to do to trick students is give you the reciprocal already. So what do I mean? They gave us 1 over 5x to the negative second power. So when we have it like this, we're going to take the reciprocal and it's going to turn from a fraction to basically a whole number. Or at least if it's in the bottom, it's going to go to the top of the fraction. So right here, guys, same exact thing, right? It's over the x squared. So if we were to take the reciprocal, we'd have positive x squared all over 5, and that would be my final answer. Now, the difference between example number 1 and example number 2 is now the negative exponent is applied to all the terms. So what does that mean? That means I have 3 to the negative 3 power and x to the negative 3. So I'm going to turn this into a fraction, and then I'm going to take the reciprocal. So now I have 1 over 3 to the positive 3, x to the positive 3. And I know that I could simplify 3 to the third power. So my final answer would be 1 over 27 x to the third power. So just be mindful when the negative exponent is over one term or just a variable versus when it's applied towards a whole entire problem. They're going to try to trick you. Now, this last example is similar to the previous example, right? And this is what we're more than likely going to see on our test or on our homework. So we're going to apply -5 or that exponent of -5 to both 2 and x to the fourth, which would give us -20 because we had to multiply the exponents, right? That's that power rule. Take the exponent and multiply with the exponent on the out. So we have x to the -5, y, 2 to the negative 5, x to the negative 20th power. So we know we have negative exponents and we cannot have that. So I turn it into a fraction and I take the reciprocal. So now I have 1 over, and we know 2 to the 5th power, I believe it's 32. And now my x to the negative 20, when it comes down, is going to be positive. But at this part of the review, guys, we're now done explaining all the laws. We're now going to do a mixed review. Please make sure you stay around for that part of the video. In the mixed review section, guys, we're now going to look at about 8 examples, and I'm going to walk you through how you should solve. So when we look at our first example, guys, we see that we have exponents on the outside, and we also have to multiply the answer from both of these separate parentheses. So I'm going to focus on multiplying my exponents. So we're going to multiply 2 times 4 to get x to the 8th. Y to the first times 4 is going to give me y to the 4th. And z to the third times 4 is going to give me z to the 12th power. And we're going to multiply that. And we're now going to take these to the third power. So y to the second times 3 is going to give me y to the 6th. And z to the first times z to the third is going to give me z to the third. Now, after we took care of that, we now could add like bases with like bases, meaning we're going to add our exponents with the same base. There's no x, so x to the 8th stays the same. Y to the 4th plus y to the 6th gives me y to the 10th. And then z to the 12th and z to the 13th is going to give me z to the 15th. And that is it. Now, in our second example, there's 2 ways we could solve this. We could take everything to the 4th power, right? And then use the quotient rule, subtract exponents, divide. Or we could do it the other way. I'm going to do it the other way. So what I'll get is 3x to the second power, because we're subtracting our exponents. And then we're going to have y to the negative 3, because when we do 3 minus 6, we're getting a negative number. Now I could take this all to the 4th power. So I have 3 to the 4th, x squared times 4, which is going to give me x to the 8th, and then y to the negative 3 times 4, which gives me y to the negative 12. So now, because I know I have a negative exponent, I turn this into a fraction. We know 3 to the 4th is 81. So I have 81 x to the 8th. And because y to the negative 12 is the only negative exponent, it's going to come to the bottom, and we'll have y to the 12th on the bottom. So final answer, 81x to the 8th, y to the 12th. Now, problem number 3. Similar to this one, we need to take 4x to the negative 3rd power. So let's just say I from off rip, I made it a fraction, right? So now I have 1 over 4 to the positive 3 x to the positive 3, because I already applied that negative exponent in the rule, right? I took the reciprocal. This is what I should get. And then now I'm going to multiply this by x to the negative 4th. So the way I would like to do this, right? Let's backtrack some, because we're going to keep this really simple. Let's say in the first step, we just applied that exponent, right? So we have 4 to the negative 3, x to the negative 3, and we're going to multiply this by x to the negative 4th. So once we add these 2 exponents, I'm going to get 4 to the negative 3 times by x to the negative 7th. Now at this step, we can now take care of our negative exponents. And what we're going to get, let's make sure. 1 comes to the top, 4 to the 3rd is going to give me 64, and x to the negative 7 is now just going to be positive x to the 7th. And this would be our answer. We're going to go on to the next few examples now. In the next example now, guys, we're working with a fraction, and we know that we have to take what's in the top half part of the fraction to the second power. And if you notice, the parentheses and exponent is only over the top half part of the fraction and not the whole thing. So when I simplify this, we're going to have negative 6 squared, which is going to give me 36. A to the 3 times 2 is going to give me a to the 6. And b squared times 2 is going to give me b to the 4th. So we took care of the top part, and now we're going to rewrite the bottom part. So what we're going to do, 36 divided by 4 is going to give me 9. A to the 6 minus a to the 4th is going to give me a squared. And b to the 4th minus b to the 11th is going to give me b to the negative 7. Now at this part, we have a negative exponent, which we cannot have. So I turn this into a fraction, and b to the negative 7 comes to the bottom. So my final answer will be 9a squared over b to the positive 7th power. Okay. Problem number 2. There's two things we have to do. We have to simplify our fraction first, and then we have to take what's in the parentheses to the third power. So let's focus on what's inside parentheses. 4 to the third power is going to give me 64. X to the 6, when we multiply 6 and 3, we're going to get x to the 18th. And y squared to the third power is going to give me y to the 6th power. So we took care of that part, and now we can worry about our fraction, right? So 10 divided by 5 gives me negative 2. When we have x squared minus 15, we're going to have x to the negative 13. And then y to the negative 5 minus 1 is going to give me what? Oof. Isn't that negative? Let me make sure. 'Cause I feel like I made a mistake real quick, guys. Y to the negative 6. Don't know why I had a little blank right there. So now that we took care of that, guys, what we're going to do now is combine our exponents. So 2 times 64 gives me negative 128. X to the 13th, when we add negative 13 and positive 18, we're going to get x to the positive 5th power, and y to the negative 6, and y to the 6. Once we add those together, we get y to the 0 power. And guys, just please make sure you remember this. Anything to the 0 power is just 1, so we don't need to write that. And our final answer would be negative 128 x to the 5th power. Now, last example here, what we need to do is focus on the bottom part of the fraction before we could subtract anything. So 15 and 5 is going to give me 75 once we multiply. X to the 7th times x to the 4th is going to give me x to the 11th power. Y to the 1st plus times y to the 1st is y squared. So we took care of that, and we rewrite what is on the top. And now we know that we need to divide our number values and then subtract our exponents. So if we divide by 3, we're going to get 4 over 25. X to the 9th minus x to the 11th is going to be x to the negative 2nd power. And y to the 9th minus y squared is going to give me y to the 7th. And just a rule of thumb, after we use this quotient rule, your answer always goes in the top. And if it's a negative exponent, like right here, then we bring it to the bottom. So I would have 4y to the 7th power all over 25x to the positive 2 power. Right? But we're going to look at our last few examples for this video. Last two problems of this video, guys, and we really hope you've enjoyed this review. If you have, smash the like button for us. So in this example right here, and then I forgot my 2. We need to take care of this fraction and then take it to the 2nd power. Or like I said, we could take everything to the 2nd power and then take care of the fraction. But once we take care of what's inside, we would get 12x to the 6th power y to the 4th. Divide 60 by 5, we get 12. 10 minus 4 gives us 6. 7 minus 3 gives us 4. And at this step now, we're going to take everything to the 2nd power. So 12 times 12 gives me 144. 6 times 2 is going to give me x to the 12th power. And then 4 times 2 is going to give me y to the 8th. And this would be our final answer. Now, in the last example, we're taking both the top and the bottom to another power. So what does that mean? We're going to multiply everything in the top part. We're going to take it to the 4th power. So 2 to the 4th power is going to give me 16. X to the first times 4 is going to give me x to the fourth. Y to the fourth times 4 is going to give me y to the 16th. And that is all over 2 squared is 4. X squared to the second power is going to give me x to the fourth power. And y to the third times to the second power is y to the 6th. Now at this step, guys, we're just going to simplify our fraction. So 16 divided by 4 gives me 4. When I subtract my exponents, 4 minus 4 is going to give me x to the 0 power. Y to the 16 minus y to the 6 is y to the 10th. We know that anything, whether it's a number or variable, to the 0 power is just 1. So I don't need to write it here. And my final answer, once I take care of that x to 0, will be 4y to the 10th power. So we really hope that this Exponents review video was helpful for you, especially the mixed review. Thank you guys so much for joining me today on Algebra 1 with Mr. Peters. Smash the like button, subscribe to our channel, and leave comments, for future videos you guys would like to see on our channel, or leave comments for questions you had on today's video. Thank you guys for joining us today.